All right, so just like a simple quadratic formula, let's review that real quick. So if I have an equation y equals x, a x squared plus bx plus c, I can calculate the discriminant, which really is just the part underneath the radical in the quadratic formula. And from the discriminant, I can determine the types of solutions for my quadratic. So in this case, I would say b squared minus 4 times a times c, and evaluate whether it's greater than 0, equal to 0, or less than 0 to determine how many solutions. Well, it turns out that with a conic section, I can also calculate the discriminant, and it will tell me the type of conic I'm looking at. So let's look at the general form of a conic section. We have ax squared, that's the same as a quadratic, plus bxy plus cy squared plus dx plus ey plus f, all equal to 0. So the standard form also with the discriminant of a quadratic, when it equals 0, I use the a, b, and c, and only the part underneath is used or is called the discriminant. So the same thing when I'm working with these. Now, in this case, I'm going to use A, B, and C, just like before, except there's also a D, E, and F. And these serve to rotate in space a conic section. We don't have the tools yet to do that after trigonometry. If we have time, we'll come back and revisit this. But in the meantime, we can use the ABC of a conic section using the exact same formula. So if I calculate b squared minus 4 times a times c using a, b, and c, and if I get that this is less than 0, specifically b equals 0 and a and c are equal to each other, then this tells me that this formula, I'm looking at a circle. So if that's what I get out, if I calculate the discriminant and I get this result, I'm looking at a circle. If b squared minus 4ac is less than 0, again, with the specifics that either b is not equal to 0 or a is not equal to c. Basically what we're saying is either one of these conditions, one or the other, is not met. So I get the same result as for a circle, but one of the conditions for a circle is not met. Then I know I'm looking at an ellipse. The last two are easier to evaluate. If I calculate the discriminant and I get that b squared minus 4ac is equal to 0, then I know I'm looking at a parabola. No conditions for that one. And last but not least, if b squared minus 4ac is greater than 0, then I'm looking at the only one left, which is a hyperbola. Okay, let's do a couple of examples. So let's look at 2x squared plus y squared minus 2x plus 5xy plus 12 equals 0. All right, so first I have to identify my a, b, and c. Well, a is related with x squared, b goes with the xy term, and c goes with the y squared term. So now I calculate the discriminant. I get, well, that's not right, 5 squared minus 4 times a is positive 2 and c is a positive 1. So that's 25 minus 8 is 17, which is greater than 0. Down here, I'm looking at a hyperbola. So I can safely say that this equation is going to give a hyperbola. So I think one more. Let's say 4x squared plus 4y squared minus 4x plus 8 equals 0. Again, first I have to identify my a, b, and c, and we know that a is associated with the x squared term, and b is associated with the xy term, which in this case equals 0, and then c is associated with the y squared term. Now, we have a little bit of a hint, because if we're looking at b equals 0, we're probably looking at a circle, but let's go ahead and calculate the discriminant. So I have b squared, which is 0 squared, minus 4 times a is 4 and c is 4. So this equals 4 cubed, 0 minus 4 cubed, which is negative 64. Which is less than 0. And so the condition that the discriminant is less than 0 and b equals 0, which is true, b equals 0, and a equals c. A and c are equal to each other. So we have to be looking in this case at a circle. And that's it. Identifying the type of conic section you're looking at using the discriminant. So you might want to flashcard the definition for the discriminant, that a, b, and c. A is associated with the x squared term, b with the xy term, and c with the y squared term. So that would be a good flashcard moment.